Hello everyone and welcome to another episode of Java Basics. Today we're going to be talking about the ArrayList class. In other words, we're going to be able to create arrays with no fixed length. Now if you missed any of the other episodes in this series, I'm going to put a link in the description below so you can catch up on anything you may have missed. I highly recommend watching the array video before you do this one because you're going to need to know some basic skills on how to use an array. Anyway, let's get going with the ArrayList. If you want to learn Java programming, or just programming in general, subscribe to this channel. We put out a lot of videos that range from beginner topics to more advanced programming concepts. Also, please like this video, share it with a friend, and write a comment as well. It goes a long way to help promote a channel like this. Now, let's get back to the video. So an array list in Java is actually a dynamic array. It's no fixed length. Let's take a look at some of the similarities and differences between an array and an array list. With an array, when you want to declare it, here's how you do it. Integer, open close bracket, and then you have your variable name. This says that numbers is going to be an array of integers. With an array list, you do it kind of similar. You have a variable, the type is array list, and in the brackets, that's the less than and greater than sign brackets, you tell it what type of variable you're going to have. And then the actual variable name is on the right. Now please notice that we're not using int with a lowercase I. We're using capital I integer. That's the wrapper class for integer. So integer with a capital I is a class that holds integers, primitive integers. And the reason why we have to use this is because with an array list, you can't use a primitive as the type of variable that's going to be stored inside the array list. You have to use a complex class. So if you want to use integers, you have to use capital I integer. If you want to store doubles, you have to use capital D double. You can't just use the primitive type. Now, in order to create and allocate the array, what we do is we say numbers equals new int, and then in the brackets, we specify the length of the array, how many elements will be stored in the array. With an array list, you don't need to specify the length because it's dynamic. You can have any number you want. And here's how we do it. Numbers equals new array list, and in the less than greater than sign bracket, normally you put the type there of what kind of elements we're going to store, but Java already knows what kind of elements we're going to store. It was specified when we declared the variable, so you can leave that out here. And in the parentheses, you don't have to specify anything. There's no parameters. We don't have to tell Java how many elements are going to be stored because this, again, is dynamic. Speaking of the length, here's how you get the length of a standard array, and here's how you get the length of an array list. Similar, one has a property of length, one has a method called size. But with the array list, you get a whole lot of other methods. First, here's the import that you're going to need in order to create the array list. Now let's take a look at some of the methods that you get. For an array list, you have to actually add the element. So we're going to use a method called add, and in the parentheses, you'll pass in the element that you wish to add. Now, if your array list is strings, the element will have to be a string. If your array list is in integers, the element will have to be an int, and so on. So the element has to match the type of what you already specified the array list will hold. Now you can also add this way. This is the overloaded method add. You can pass in not just the element, but the index where it should be added. So you're not limited to just adding an element at the end of the array list, tacking it on at the end. You can actually add it in the middle, and Java will take all the items in the array list and shift them over to make room for your new element. It's a very handy feature. Here's how you remove an element from your array list. You pass in the index, and Java will remove that element from the array list. Now, you're not going to have a blank spot. What's going to happen is Java is going to remove that element, and it's going to shift everything over so there's no blank spaces. And of course, this method will return the element that's being removed, just in case you need it. If you don't, just ignore the return type. This is how you actually get an element from an array list. Now, with a normal array, it's a little simpler. You just say variable, open square bracket, and then the index that you want, and there's your element. Here you actually have to use the get method. So you'll say numbers, whatever your variable name is, numbers was what we used on the prior slide, dot get, and then you pass in the index, and that will return the element at that index. You can also set the element at a certain index. This will replace whatever was previously stored there. It will replace it with whatever you pass in. But there are a whole bunch of other methods that are very handy. For example, these two, index of and contains. What these two will do is they'll search the array list to see if the element exists in there, the element that you're passing in. With the index of method, if the element exists, it'll return the index where it found it. With the contains method, it'll look for where the element exists, and if it finds it, it'll just return true. False if it's not there, true if it is there. Now there's another really handy method called sort. And the way you do that is you call collections.sort. So collections is a class, and you're going to call the sort method on that class, and you're going to pass in your array list that you wish to sort. Now you just have to be careful here. One is that when you call sort, it's actually going to modify your array list. It's not going to return a sorted array list different from the one you originally had. It's going to actually modify and switch around the elements in your array list so it's now sorted. So you have to be careful with that. The second thing is if you're sorting strings, Java knows how to do that. It just makes it alphabetical. If you're sorting numbers, Java knows how to do that too. It makes it numeric. But if you're sorting a custom class, Java's not going to know how to sort it. For example, if you have a class car, each car has a make, a model, a year that it was made, number of doors, number of passengers it can hold, the engine type, a whole bunch of other things. Java doesn't know, given two cars, which one comes first when it's trying to sort. So when you're going to sort something like that, you have to have a new class called a comparator. And that comparator will tell Java, given two objects, whether they're two cars or two houses or whatever, this is how you determine which one comes first when you're trying to sort. Now we're going to get into all of those kind of examples later. We're going to start by going to NetBeans right now and creating an array list and starting with the basics. All right, here we are in NetBeans. Now, as you can see, I'm going to use my class that I used for the array video called Learning Arrays. I do have my import. I already put my import in for the array list. So now what I'm going to do is I'm going to actually create an array list. So array list, and then in the less than greater than sign brackets, I'm going to create the type. So let's say we have an array list of strings. And now I'm going to name my array list. We'll call it names. And that's going to be equal to a new array list. And then I have my brackets and my parentheses. Okay, again, this is blank. I don't have to re-specify the type. And there's nothing as the parameter because I don't have to specify the length or anything else. So now I have a variable names, which is my array list. Let's populate this array list with some information. So first we'll say names.add, and we're going to add a name. Okay, let's add some more. Okay, so here we go. We have 4 of them. And that's great. So now one thing that you can do with an array list, which is quite nice, is you can print it. And you won't just get the memory address where the array is starting. You're actually going to get a nice, neat list of elements. So here we go. Let's try this. And as you can see here in square brackets, it gives you the list of everything in the array list. It's quite nice. You don't have to do any kind of a loop or anything if you want to print it. Of course, if you don't want to print it this way, you have to write it yourself. So here we have our array list. And now what we're going to do is we're going to add a new item. So let's add a new item. Okay. And now let's print it again. Now when we add a new item, it adds to the end of the array list. As you can see, Beatrice has been added to the end. Now what happens if we want to add Beatrice in the middle? Let's say we want to add Beatrice at position 1. So between Michelle and John. So we would use the overloaded add method. We would pass in a 1 first. So now what Java is going to do is it's going to take everything at position 1 and beyond and move it down like this. So it adds space for Beatrice to be inserted between Michelle and John. So let's run this and see how it works. As you can see, Beatrice has been added at position 1, and it took everything that was at position 1 and beyond and shifted it to the right. So now what happens if we want to just get one element? So normally, let's say we want to print the element at position 2. So in this case, it would be Michelle, Beatrice, John. It would be printing John. So normally what we would do is we would print names of 2. But you see, this doesn't work, not with an array list. In order to do this, we have to use the method get, and we pass in the number 2, the index. This will return the item at position 2. In this case, it would be John. So here we should just be printing John, which is exactly what we expect. Okay, good. Now let's modify something. So let me go back to printing the entire array list, and we're going to add Beatrice. But instead of adding Beatrice, what we're going to do is we're going to set element 1 to Beatrice. So right now we have element 0, element 1, element 2, element 3. We're going to change element 1 to Beatrice. So John is going to be modified. Let's run this, see how it goes, and there it is. John was modified to Beatrice. Perfect. Now what happens if we want to remove something? Let's remove the element at item 1, at index 1. So we're going to remove John. As you can see, John has been removed. Now this method will return a string because this array list holds strings. So technically I could say string removed element equals, right? And then I could print, and if I run this here, you can see that it will remove John and then it prints John down here. Now let's get the size of our array list. So let's print here names.size. Okay, similar to the arrays where you just do, oops, I forgot names. Similar to the array where you do .length, here you have to call a method .size with open and close parentheses. So here we should be printing the size of our array list. So let's just do this, size of array list. All right, there we go. So now let's run this, and you can see that the size of the array list is 3. Well, why is it 3? Well, it was really 0, 1, 2, 3, so it should be 4, but don't forget, we removed one, right? We removed one. So after we removed one, now the size of the array list is 3. That's different than an array, whereas if you delete one of the items in an array, it still has that spot, that placeholder there, which is nothing in it. So technically the array would still be the same length. Here the array list is actually removing the element, it's getting smaller. So now let's try and sort this array list. So it's strings, Java should know how to do it. So let's actually get rid of all this code here. And let's try and sort the array list. So when we print the names, we're going to print before sort, not sort, there we go. Okay, now let's sort. So what we're going to do is we're going to say collections, it helps if I could type, collections.sort, and we're going to pass in names. Of course, here we need to import collections. So just so you know, here's the import statement. So now this is actually modifying the array list. So the array list is changing. It's now going to be sorted. So if we print it now, let's copy this code, print it here. We'll say after sort. When we run this, as you can see, Java knows how to sort strings. It does it alphabetically, and that's perfect. Now, before we get into more advanced versions of sort where we use custom classes, let's first try contains and index of. So we've sorted the array. Let's take a look to see if the array contains the name Doug. Obviously, that's going to be false because Doug's not part of our array list. But if we try John, this should return true. As you can see, it returns true. Now, instead of using contains, we could use index of. Okay, let's look for the index of John. And when we do that, we should get 1. And we do. 0, 1. Of course, if we look for Doug and we do index of, you could see that it returns -1. -1 is an indicator that says it was not found. So technically, you really don't need to use the contains method. You could just use index of and check to see if the result is -1, and that would indicate that it's not there. But sometimes it's just easier for you to use a Boolean, so you can use contains. So now let's try and sort a complex class. So I actually have created a class called student. So what we're going to do here, student is just going to be a basic, say, student in one of your classes. Let's just say you're a teacher. So we're going to have a couple of instance variables. It's going to have a name, and it's going to have a height. Okay, and then we're going to create our constructor, and our constructor will pass in the name and the height. And of course, it's going to set those variables. Okay, let's write a couple of getter methods or accessor methods. And we want to be able to print our student. So in order to print our student, we're going to write a tostring method. Public, and this will return a string, and the name of the method is tostring. And just in case you're not aware, if you want to actually create a student and then just say print student or system.out.println student, Java is going to print the memory address of the student. But if you create a method like this in your class, it has to be exactly like this. It has to be named tostring, no parameters, and it has to return a string. Java will use that to print whenever you print something of type student. It'll call this method if it exists, and whatever this returns, that's what Java will print. So this way we can actually just print our student and it'll look nice instead of having an ugly memory address. So what are we going to print when we try and print a student? Okay, there we go. This will allow us to print our student. So now let's get rid of all this. Here, we don't need this, okay? So let's create an array list, but instead of a string, let's create an array list of students. And we'll call it just S. And now let's actually create this array list. Let's add a few students. So we'll do something like s.add. And what are we going to add? We'll add a new student. And the student's name will be Mike. And their height will be 65 inches. Okay? And let's make 5 of them. So we'll have Mike, we'll have Donna, we'll have George, we'll have Zach, and maybe we'll have Betty. All right, and then for the heights, we'll have, I don't know, 65. Let's go, Donna's really tall, 67. George is, say, 58. Zach can be, I don't know, Zach could be maybe he's young. Maybe he'll be like 47 inches. Maybe he'll be like a elementary school or junior high school. And then Betty will be, let's just go with 55. Okay, so here we go. So now if we print, let's print this and we will see, and there it is. Okay, Mike 65 inches, Donna 67 inches, George 58, and so on. Okay. So here we've printed our array list and it looks fine. And again, it's using the tostring method in order to print. So now what we're going to do is we're going to sort this array list. So we're going to say collections dot sort, and what are we going to pass in? We're going to pass in S. But notice that it's not compiling. And the reason why it's not compiling is because S is not a type that Java knows how to sort. It doesn't know how to sort. How do you sort a student? Does Mike come first? Are we sorting by name? Are we sorting by height? What are we sorting by? So we have to tell Java how we're sorting it. And the way we do that is we have to actually create a comparator. So we go into the student class, and after the final bracket, after we close the class, we're actually going to create another subclass of student in the same file. So we're going to say class, and we're going to call it student name comparator, and it's going to implement comparator. And we have to tell it the type of information that's going to be in there. Now inside these brackets, we're going to create a method called compare that Java is going to look for. Okay, and then in this method, the responsibility is, the expectation inside this method is for you to return a number. When you're given two students, you have to return a number. You're going to return -1 if this one comes first. You're going to return positive, well, not -1. You're going to return a negative number if student 1 comes first in your sort. You're going to return a positive number if student 2 comes first. You're going to return 0 if they're the same. Now you notice this is underlined in red because we need an import, and just so you know, there's the import. So once again, this method should return negative if this comes first, positive if this comes first, and 0 if they're the same. Well, we're going to compare by name. So what we're going to do is we're going to use a method called compare2, which is a method on the string class, which does exactly that. Okay, so let's take a look at what's happening here. The first thing we're doing is we're getting the name from this student. We're using the compare2 method, passing in the name from this student. So compare2, if you're not familiar with this method you call it on a string, you pass in another string that it should compare to, and this method will just return a negative number if this one's first, a positive number if this one's first, and 0 if they're the exact same string. So we're just going to use that method here and return whatever the result is. But we want another comparator. Let's create 2 of them. This one will allow Java to sort by name. How about we have one that allows Java to sort by height? So let's just change this. Obviously, the return thing has to change. Now, what do we want to return? Well, again, we want to return a negative number. It doesn't matter which negative number. We have to return a negative number if student 1 comes first. So we're going to try and sort by height. So we're going to assume that student 1 will come first if student 1 has a smaller height. So all we really need to do is s1.getHeight minus s2.getHeight. What that's going to do is if student 1 has a smaller height than student 2, this will be negative. If student 1 has a bigger height than S2, this will be positive, which means student 2 comes first. If they have the same height, this will return 0. So here are our comparators. These are instructions to Java how to compare 2 students when we're sorting. Now we're going to use that. Here, we're going to pass in, we're going to create a new comparator. Just like that. We have this class. We're going to create a new one and pass it in here. So this will tell Java, sort this array list, use this as your comparison. Let's print out the array list. After this, here we go. After name sort, and then let's do the exact same thing, but this time we'll use a height sort. So we'll use student height comparator. And let's see what happens. So before sort, we get Mike, Donna, George, Zach, Betty. There's no sorting involved. It's exactly the way it is here. After the name sort, however, look at what we have. Betty, Donna, George, Mike, and Zach. It's sorted by name. Now we sort by height. Look what we have. We have Zach, but 47 inches, 55 inches, 58, 65, and 67. It's a very handy tool to be able to sort, but you have to tell Java how it's going to sort so it knows. And that's the array list. I mean, there's other things that you can do with the array list. We're not going to cover everything in this video, but we've covered the basic stuff and some more advanced stuff. So I hope you got something out of it, and I hope you can use ArrayList to your advantage from now on. I hope you learned something from watching this video. Please remember to subscribe and share this video with others who are learning Java programming. Thanks for watching, and take care, everyone.